An important skill that we need to have as well is determining the equation of a particular graph. So for example, here's a question. Determine the equation of the given graph in the form f of x is equal to a times b to the x plus q. And even without this given to you, you should be able to identify that that's an exponential graph, and so it's going to be, the function is going to be of the form y is equal to a times b to the x plus q. And it's important to be able to reason about these parameters straight away. So because it's a graph that's going this way, an increasing graph, we know that b must be some number bigger than 1. So it's not a proper fraction, otherwise it would have been going like that. The next thing to look at is the fact that it's above the asymptote, so it hasn't been reflected, right? So because of that, we know that a is not a negative number, a is some positive number. And then finally, speaking of asymptote, a very good telling factor if you're trying to determine what q is, has the graph moved at all? And because the asymptote is the original asymptote, so to say, then we know that our graph hasn't moved. So that's the first thing you can say, really, that q is equal to 0 because your graph hasn't moved up or down. So your function is of the form a times b to the x, and q is a non-factor there. And then there's 2 points you've been given. You've been given the point, the y-intercept, which is 0 and 3, and the other point you've been given is 2 and 12. So like I said, those are input-output pairs. So that means that when my input is 0, my output is 3. And when my input is 2, my output is 12. So that means that a times b to the 0 is equal to 3. And a times b squared is equal to 12. This is actually a useful equation because b to the 0 is just 1. So this is telling me that a is equal to 3, which I can then substitute over here. So 3b squared is equal to 12, which means b squared must be 4. And so because we know that b is always positive, then we don't say b is positive or negative 2. We know that b must definitely be 2. And so your final answer would be that y is equal to 3 times 2 to the x. Let's look at another example. Alright, so I haven't written a formal question to this, but the idea is, determine the equation of the following graph. And again, you need to be able to look at the shape of your graph and categorize. Is this a linear function? Is it an exponential function? And because this is a parabola, then we know that it's a quadratic function. There's a squaring of my input happening. So, the general form currently of a parabola is, y is equal to ax squared plus q. And this point over here is a nice telling sign of how far up or down my parabola has moved, because typically this turning point sits over here. So that tells me that q is equal to 2. The graph has moved up by 2 units. So y is equal to ax squared plus 2. And then, of course, I can use this point to figure out what a is, because this is an input-output pair. When my input is negative 1, my output is 6. And I can solve for that. So minus 1 squared is just 1. So I've got a plus 2 is equal to 6, which means that a must be equal to 4. And that makes sense. I've got a smiling parabola, so it makes sense that a is a positive number. And so then the equation of your graph would be y is equal to 4x squared plus 2. Sometimes, though, they're not going to be you know, the nice features that tell you how far up something has moved. So for example, you might have something like, right, so here we go, we're given a graph, we're told that it's of the form y is equal to a times b to the x, so it hasn't been shifted up or down, and we can see that it hasn't really. The asymptote is still the x-axis. You're asked to determine a and b, and so all we have to go on here are these 2 points, these two input-output pairs. So on the one hand, we know that when my input is -2, my output is -9/2, and we also know that when my input is 1, my output is -4/3. So this guy, for instance, just means that AB is equal to -4/3, and this guy we can rewrite to say, well, A/B squared is equal to -9/2. So let's call this equation number 1, and we'll call that equation number 2. So what we could do there is we could express one variable in terms of another and substitute that into the second equation. So for instance, I would take equation number 2 because it looks simple enough. AB is equal to -4/3, and if I divide both sides by b, for instance, then what I have is just a over here, and -4/3 divided by b, remember that that's just the same as multiplying by 1/b, and that would just be the same as -4/3b. Oh dear, I'm too eager about erasing that. So that would be -4 divided by 3b. So now I've got an expression of a in terms of b. So I'm going to take that and put it into my first equation. So according to my first equation, A/b squared is equal to -9/2. And so then I substitute that there. And maybe it might be easy because I'm going to have a fraction divided by something else. So I'm going to write it as -4/3b divided by b squared is equal to -9/2. And that divide by b squared is just the same as multiplying by 1/b squared, right? And so then you've got -4 times 1, top times top, which is just -4. And at the bottom you've got 3b times b squared, so that would be 3b cubed. Okay, so that's quite a squashed thing there. But yes, that would be -4/3b cubed. And so then we're trying to figure out what b is. Nice thing to do might be to get a common denominator. So I'm going to make my common denominator 6b cubed, both sides. Please never write fractions like this. This is just a space constraint situation. So in order to go from this to 6b cubed, I would need to multiply it by 2. So the top is going to be -8. And on this side, to go from this to 6b cubed, I need to times by 3b cubed. So I'm going to have -27b cubed. And now that my denominators are the same, I can just look at my numerator. So -8 is equal to -27b cubed. So that is the current state of my equation, and I can just solve it from there. So trying to get b by itself, so I'm going to end up with 8/27. The negatives cancel out, and if you take the cube root of that, you should get 2 over 3. So now I know that b is equal to 2 over 3, and what's left is for us to figure out what a is. So since we know that a is equal to negative 4 over 3b, we're just going to sub that in there. And I find that the easiest to use because a is already isolated in that equation, which of course you could use any of the other two equations that we started out with. So you would have a is equal to negative 4, and again, because I'm going to be dealing with b being a fraction, so 4 divided by a fraction, I'm just going to write it out as a division. 3 times 2 over 3, and that would be negative 4 divided by 2. Okay, I spoke too soon. And that would just be negative 2. And so visually that makes sense as well. You've got b is equal to 2/3 and a is equal to negative 2. So a being equal to negative 2 tells me that this graph has been reflected, which makes sense, right? If a was positive, then your graph would have been there. Okay, and that actually brings us to the second point. So this confirms that b is equal to 2/3. You know, is a kind of a valid answer in terms of our reasoning, because you know, if it hadn't been reflected in the x-axis, then this is what the shape of the graph would have been, which is in tune with b being a number that's between 0 and 1. We expect that it would be a decreasing function, and then a being negative would cause it to be reflected and to look like this. And of course, another way that you could have gone about solving this that some of you illustrated last term is, so to start out by writing down those two equations using your input-output pairs. So when my input is negative 2, my output is negative 9 over 2, and when my input is 1, my output is negative 4 over 3. And so you have basically AB is equal to negative 4 over 3, and over here you've got, you know, you could write it however, A over B squared is equal to 9 over 2. And so what some of you then did was you isolated, for example, A in both equations. So then you've got, for instance, on this side you'll have A is equal to negative 9 times B squared over 2. So if you've times both sides by B squared to get rid of this guy, so then you're left with A on the one side of your equation. And then using the second equation, so this guy over here, you have A is equal to negative 4 over 3 divided by B, and again say that's the same as timesing with 1 over B. So that would be negative 4 over 3b. And so you have, on the one hand, a is equal to negative 9b squared over 2, and on the other hand you have a is also equal to negative 4 over 3b. So that must mean that negative 9b squared over 2 must be equal to negative 4 over 3b. And again, you could find a common denominator in this case, could be 6b. And so on the one side, you'd need to times by 3b top and bottom, you'd have 27b cubed. And on this side, you would need to times by 2 top and bottom, so you'd have negative 8. So we end up with the same equation to solve ultimately, but this is a much cleaner way of arriving at that. Let's look at one more example. Okay, so here we have a parabola. So we're thinking squaring my input, something that looks like y is equal to ax squared plus q. And we can see that there definitely is, you know, a is not just 1 because this parabola has been flipped around, and q is also not 0. This is a parabola that has shifted. So both a and q are values that we need to figure out. And again, we've been given two pieces of information. We've been given 2 points. When my input is -1, the output is 1, and we can simplify that. So that ends up being a plus q is equal to 1, and when my input is 2, my output is -8, and that simplifies to 4a plus q is equal to -8. So there are my two equations. And so I would say, okay, take one and express some variable in terms of the other. So maybe a is equal to 1 minus q, and put that into 2. So 2 would become 4 times 1 minus q plus q is equal to -8. And so 4 minus 4q plus q is equal to -8. 4 minus 3q is equal to -8. So we have minus 3q is equal to minus 12, and q is equal to 4, which visually makes sense, right? Our graph has shifted upwards, so it makes sense that q is a positive number. And so then if I substitute q in here, for instance, or you could put it into this equation, this is actually the nicest for me, I can then see that a must be -3. -3 plus 4 gives me +1, and so that would be the other part of my solution. And so remember that the question asks you to give you the equation of the graph, so you wouldn't just stop at that. You'd actually need to say that the equation of your graph is y is equal to -3x squared plus 4. And of course, you could have done it the other way, where you rewrite both equations and isolate some variable. Maybe the easiest one would be to isolate q and then make those two equations equal to each other. That's also a perfectly valid way of going about solving for a and q.